Recal, chapter 1.5, solving inequalities. Interval notation is when we have an inequality, which is a range of numbers that could be a solution for an equation. The closed interval is inclusive. It means it includes that number. If you write it as an inequality, it has the or equal to symbol with it. An open interval is exclusive. And that means that it does not include that number. So that means if it's like less than 4, it means 4 does not work, but everything less than 4 does work. So inclusive and exclusive. Half interval, you can write it. It depends on what you've got going there. Infinity, which we will deal with, is this symbol. Oops, sorry, that was kind of terrible. It's the little sideways 8, infinity, and it is always exclusive because you can't actually attain infinity. It's not really a number, it's more of an idea. So it's always exclusive. So we're going to write these using interval notation. From 1 to 3, you always write from the least to the greatest, so left to right. These are both inclusive, so we're going from 1 to 3 with the hard brackets. From -4 to 0, this is saying -4 is less than x is less than 0. Because it's not got the or equal to, we write it with the parentheses or the soft brackets. X is greater than 5, that means that it has to be bigger than 5, so we're starting at 5. It doesn't have the or equal to, and greater than 5 doesn't have a top restriction, so it's going to infinity. And then less than or equal to 1, if it's less than or equal to 1, then the lowest it can be is negative infinity, which has to have the open interval, and or equal to means we have that hard bracket there. So now we're just going to kind of do the opposite. Whenever you write the compound inequality like this, which means you have an inequality on both sides of the x, it's always the least, a less than, your variable, a less than, and then the greatest number. So here, this one is going to be less than or equal to, and then less than because of the hard bracket and the soft bracket. So we have 1 is less than or equal to x is less than 4. From 2 to infinity, this is exclusive, which means it doesn't have the or equal to, means that x is greater than 2. From 2 to 3, both of those are inclusive. So we've got 2 is less than or equal to x is less than or equal to 3. And then from negative infinity to -3 means that x is going to be less than or equal to -3 because of the hard bracket. So x is less than or equal to -3. All right, so now we're just going to solve these inequalities. Remember, when you're solving an inequality, if you divide or multiply the inequality by a negative, then you have to flip the sign, so you flip the inequality. So I'm going to divide both sides here by 2, just like normal. That was a positive 2, so it doesn't change my inequality. X is less than 3. If we were to graph that on a number line, we have a 3. If it's less than 3, that means it's not or equal to, so it's an open circle, and we shade to the left. To write it as an interval notation, it's less than 3. So if it's less than, that means our furthest down, our lowest value is going to be negative infinity, and then our highest value is 3 there. It's not inclusive, so it's a parenthesis. So, oops, sorry, that is going to be our solution set. Number 4, I want to get my x's together, so I'm going to subtract 2x from both sides. I have 2x plus 7 is greater than or equal to -3. Subtract 7 from both sides. 2x is greater than or equal to -10. Divide both sides by 2. I divided by +2, so it does not flip my inequality. X is greater than or equal to -5. If I'm graphing this, greater than or equal to means it's a closed circle at 5, and I'm going greater than. If I write this as an interval notation, then if it's greater than or equal to -5, then -5 is the lowest it can be. It's or equal to, so it has that hard bracket. and then we're going to infinity. Number 5, we have a compound inequality. So you can do this all at one time, or you can separate it. If you separate it, you have -5 is less than 3x minus 2, or you have 3x minus 2 is less than 1. You can do it separately, or you can do it at the same time. I like to do them at the same time. The only thing is I've got 3 sides that I'm doing something to. So if I'm getting rid of this 2, in order to get rid of it, I have to add it to both sides here. So I've got that 2's gone. I have -3 is less than 3x is less than 3. Then I'm just dividing, and again, I have to do it to all 3 sides of this equation. And I get -1 is less than x is less than 1. So this would be the solution to this top equation, and this would be the solution to this equation. When you put them together, you have that compound inequality because it's less than on both sides. -1 is less than x is less than 1. If we were to graph it, we have -1, 0, and 1. They are not or equal to, so it's open circles, sorry, on both ones. It's x is greater than -1, so we're going here, and then it's less than 1, it's in between. So for our interval, we've got -1 to 1. For absolute value inequalities, you're going to split it up the same as you would an absolute value equation. You're going to have x is less than 4, and you're going to have x and -4, but when you flip the sign, you also have to flip the inequality. So I've got these 2 equations, x is less than 4 and x is greater than -4. This one can be written as a compound inequality, where -4 is less than x is less than 4, or -4 to 4. -4 to +4, open circles on both, and everything in between. On the back, solving again, we have another absolute value inequality. This one I'm going to split up. I have 2x plus 4 is less than or equal to 3, and I have 2x plus 4 is greater than or equal to -3. And I'm solving both of these equations. So I'm going to subtract 4 from both sides. 2x is less than or equal to -1. Divide both sides by 2, and I have x is less than or equal to -1/2. Here I'm going to subtract 4 on both sides. I have 2x is greater than or equal to -7. Divide both sides by 2. I have x is greater than or equal to -7/2. This one, if you can write it as a compound inequality, -7 over 2 is 3.5, -3.5. And -1/2 is -0.5. So this is smaller than that. So x is greater than or equal to this -3.5, and less than or equal to this -1/2. So my compound inequality would be from -7/2 or 3.5 to -1/2 inclusive, because they're both or equal to. Number 8, we have x is greater than 3, and we have x is less than -3. If x is less than -3, that one would shade this way. If x is greater than 3, it would shade that way. So this one you can't write as a compound inequality because there's a gap in between. If we write it on a number line, we have our -3 and our 3. If x is less than -3, we have to shade this way. If it's greater than +3, we have to shade this way. So this one is going to be 2 separate interval notation. We'll have it from -infinity to -3. And then this is called a union, which just means and from -3 to infinity. It's just a symbol that means it's both of these things satisfy this equation. And then our last one, I'm going to split this up. I have 2x minus 5 is greater than 3. and I have 2x minus 5 is less than negative 3. Add 5 to both sides. 2x is greater than 8. Divide both sides by 2. X is greater than 4. So if I were to graph that on a number line, I'm going this way. Add my 5 to both sides. 2x is less than 2. Divide both sides by 2. X is less than 1. So because 1 is less than 4, there's a gap in between. So this means that my solution is this when I put them both on the same number line. So because it's that, I've got from negative 1, or I'm sorry, from negative infinity to 1, union 4 to infinity. And that's it.